What's up? All right, man. Give me a second. We can see who all shows in here. There's Oakley. Yeah, y'all hang with me. I put that password in. There've been some people breaking in. We ain't had any problem in Northwest, but they've been some. They sent us a thing out to start using that password. There was my wife was teaching kindergarten, and they were telling her with her school that there was some kid doing like a second or third grade class last week, and a bunch of guys broke into it and exposed themselves to the whole class. Some crazy people on here. So they're trying to make sure nobody breaks in, does something stupid. Anyway, thought that was kind of crazy. Thought y'all find that weird. Now bear with me, we'll give everybody a minute to get here. So I've got our waiting rooms, we can make sure we recognize them. If anybody else shows up. No, Hallie had to go get called into work. I am recording it, so I don't know how to do it, but I think I can have it show up on our class page where they can go watch back over it. So bear with me. We'll give everybody a second to get here. So we have a few more come in. I know it's amazing how we can all get to class on 9 o'clock, but now once we're now that we're all home, it's impossible to get everybody to come together. So may have to get everybody to try to not work quite as much and try to figure out what time we can get together. Yeah, we have to turn in timesheets on Wednesday morning, and I'm trying to get mine in before this meeting, and I've got one teacher that turned it in wrong, and I've had to make them redo it. So we have to do the fun with timesheets, which is kind of irritating some of my faculty. So we never done timesheets before, but I guess it's something new. It's something new all the time. All right, that may be all we got. I'm just going to see if we got anybody else. All right, fine, folks. All right, well, I'm going to go, and y'all can ask questions. 8 by 5, or y'all can unmute yours or whatever. If y'all have a question, please, and ask any questions as we go through this real quick. We'll look at chapter 22 today, and then we'll look at chapter 23 tomorrow morning. Okay, and I'll try to set that one up at 9. I was dragging this morning trying to get this stuff in. I did my time sheet, but then I got 2 or 3 teachers that always wait the last minute to turn stuff in, so I had to round them up. I did not get my PowerPoint fixed yesterday, so we're going to use that viewer screen. So just bear with me. I'm going to share the screen. Okay, y'all bear with me. Please ask some questions. All right, let's see. I think this may be the quickest way to do it. Just go to another one like this. Hang on. Bear with me. I think this will work just as well on it. And you can tell it's a long chapter, so I'm not going to read every single thing. Okay, is everybody still with me? Y'all still hear me? Y'all okay? Can y'all hear me? Okay. All right. Now, it's actually a pretty fun chapter. The only problem I got with this is I'm just going to have a hard time doing the questions I like to do. One of the questions I like to do here is for you to know the pathway of the food to the digestive system. And I think that may be, I may put it on the test. I've got to make that test out for Thursday. I haven't made it out yet, but that's one that I actually enjoy looking at. I'm going to kind of hit the highlights as we go through it.
How many questions are we looking at on here?
No,
like on the test?
I have no idea. I haven't done it yet.
Okay.
I haven't made it out. So I'm thinking it's going to be probably 50 multiple choice. I'm going to have to handwrite every one of them. So we can't Google the answers, and I'm going to do some short answer questions, but I'm going to limit y'all to about 30 minutes to an hour. So
it's going to be like a normal test.
It's going to be, but it's going to be a virtual test like y'all had of the day, except that we all won't be able to look up the answers, and I'm going to have short answer, and you'll have to type your answer in, and I'll have to hand grade it.
Okay.
So it'll take a little bit of trouble. But that's what the other teachers have done, and it seemed to cut back on the cheating a little bit, where we can at least see some kind of grade distribution, if you follow me. So it'll be probably 50 questions, multiple choice, and then probably another, 10 short answer questions that you have to write something in. So that's going to give you time where you don't have time to go looking for other answers, okay? And we're going to try to get everybody to do it that morning. Probably try to set it up between 8 to 10, 8 to 12, maybe see how many can do actually right at 9 o'clock or whatever. Okay, so I really would like to try to do that. And I may have y'all do this, maybe log into Zoom when you're taking it. And I'll be on all morning watching y'all. At least I'm watching you a little bit, and y'all get your camera on, take a bath if you need to. I know y'all look fine, okay? But I do think that at least having Zoom set up, because I don't think any of y'all taking the test on your phone. You should have both of those, I would hope. But anyway, that's a good question, fair question, okay? But the first thing here is, one of the things I always like is just knowing the flow of the food through the digestive tract, right? So what we're going to see is we're going to start the mouth and work our way down to the anus. And I would like for you to know everything that happens in each step. Now, obviously, I'll have to break it down into this question, but I may put that on the test as a discussion question. Just kind of walk me through what happens each step of the way. Some of my favorite questions is how people have the food going from the stomach to the lung. I didn't know the lungs were involved in digestion, right? There's some pretty weird answers over the years, but that's usually one of my, like a 10-point discussion question, but I don't know if I want to make one that long on y'all's test on Thursday. I may have more answers tomorrow, Oakley, because I'm going to try to work on it this afternoon, but I haven't had time to do it. I've got administrative crud and that fun stuff, but we're just going to run through them real quick. But that is one of my favorite questions. So I may have you outline the flow of the food through the digestive system and kind of what happens each step of the way. I think that's pretty fair, pretty simple question. Okay. The main function then is real simple, is to break these nutrients down and to put them into a form that can be absorbed in the body so that the cardiovascular system then can carry food to every cell in the body so you can do everything you need to do to stay alive. So therefore, look at that. It's where we get a lot of our water, electrolytes, and all the vitamins and minerals that we get in our digestive system, which is going to be the next chapter, where it's going to be really a lot of multiple choice questions on vitamins and minerals, which I think are pretty standard. That's what I usually do on my regular test anyway. So that works out pretty good. Okay, so then of course we got excretion at the end, where we got to get rid of the waste products, things that can't be absorbed. Okay. All right. Other ones here, obviously, all the way down, we got to have a lot of enzymes and chemicals to help us break the food down, lubricants so you won't tear a hole in your esophagus and your stomach, et cetera, et cetera. So we'll walk our way through all that. There's a good term. Peristalsis is the waves that push the food through the digestive system. That's a pretty standard. That'd be a probably high probability term. I'll probably go put some terms on here. Matter of fact, I thought about doing that because that makes you have to write out the answer. Y'all know I like terms. It's just going to take a little bit longer to grade it, but it's hard to cheat on terms because by the time you start Googling answers, you're going to run out of time. Okay, so anyway, but that's a key term, peristalsis. Okay, so basically, digestion is going to break it down mechanically. It means to break it down into smaller polymers, right? Remember, proteins are made out of amino acids. Sugars are made out of simple sugars. So same thing, we did go back to that chemistry chapter back in A&P 1. We're looking at that kind of again. Then we got to absorb it into the body. And then at the end, when we get everything out of it we can, there's still a lot of carbohydrates like starches that we can't break, the cellulose that we can't break down. And then we defecate that out, fancy name for number 2, right? And then, of course, feces, okay? The membranes itself, let's go down here a little bit. I'm not worried about cavities per se. If we cut the cat, there is this structure called a great omentum that covers up the gut, so you have to take it off. It's kind of like a big old drape over the cavity. Kind of weird. All right. Get on down to something interesting. We hit on this one in the cardiovascular chapter, but if you remember, all of the abdominal artery carry blood to all the digestive organs, but all the veins drain into hepatic portal veins, so they go to the liver first. And that was kind of a big deal. Remember how the liver is going to process all the food. This is why Tylenol is real dangerous. People who eat a bottle of Tylenol, it kills their liver, and that's liver poisoning. Same thing with alcoholics with their liver being killed. So everything we drink and eat goes straight to the liver first before it goes to the regular circulatory system. We kind of covered that in the cardiovascular. You may not remember that, so just throw that out there. It's kind of cool. I'm not going to go into how the nerves all control it, but like we talked about, there is a big theory of an old other nervous system that we may start breaking it down into. Now the tube itself, take a look, has the same structure all the way through. I like a picture. We're going to cut through some of all of these darn. She goes overboard with her. I'm going to get dizzy, I can tell, with all these stinking. She writes everything out. But if you'll notice, all the way from the esophagus all the way to the anus, you have 3 layers. You have the epithelium layer, that's the mucosa, right, with simple columnar mainly, stratified squamous epithelium, remember, going all the way through. Then you have 2 muscle layers, one that runs, it squeezes the tube. This one is going to squeeze the tube down. Think of it like this, squeezing the tube down, and the other ones run with the tube, and they are going to cause the waves that push the food through. So it's almost like if you ever take a water hose and pop it. See, that blows all the water out of the hose if you were trying to drain one before you throw it in your car. And so that longitudinal muscle causes the whooping motion combined with the circular muscle squeezing. That creates those peristaltic waves that blow the food through the digestive system, and it quite violently sometimes, as some of y'all know. I'm just joking. But anyway, then the outer layer is just connective tissue. And she kind of goes on and on about that. And she goes into, y'all can read, I'm not going to read all that too, but you can read about how the nervous system kind of controls it. Hormones also play a big role. There's a whole, remember we had a whole list of digestive hormones. I'm not going to go through all those again. They may pop up in a little while. All right, so here we're going to start running through it's a pretty simple chapter. I think the more difficult chapter is the metabolism chapter, which I really do wish we could I really wish we could have class for that one because it's a hard one. But if you'll take a look here, we're just going to start the mouth, and we're going to work our way down to the anus. Digestion begins in the mouth with the salivary glands making mucus that breaks down food. So we actually mechanically and chemically break down food in the mouth. There's my dog going off, crazy dog. When we swallow, it's called a bolus. So bolus is a fancy name for the chewed food that swallows down the esophagus. Okay, we'll look at that. We'll go some pictures of that. All this just random stuff here, the lips and all involved, blah, 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 blah. Let me get on down to there we go. So a couple of interesting things here. The uvula in the back of the throat, and we've all seen that probably with our little cousins or little brother and sister. That is not the tonsils. The tonsils are on the sides here. But this actually is what covers up the upper respiratory so you won't blow food out your nose. And little kids, when you're eating, you ever remember seeing little kids eating and they blow food out their nose? That uvula has not properly sealed. So when we swallow food, the uvula closes up the upper respiratory so you don't blow spaghetti through your nose. Which some of y'all probably got some kids pictures of y'all parents feeding y'all when y'all were little and you did blow it out your nose. And then the epiglottis covers up the trachea so that we don't blow it down the air path, down toward our lungs, which would be bad. So basically that food is going to slip right back here and go down the esophagus to the stomach. Okay. Any questions on that? Kind of simple one there. Isn't that kind of cool? How the uvula closes off the upper respiratory, the trachea covers off the lower respiratory, and that peristaltic wave just flows it all the way through. So swallowing is an autonomic thing. You can put your hand on your neck and swallow some spit, and you can feel it, reach up, grab it, and pull it all the way down. Now don't do this one, but vomiting is the opposite reflex of swallowing. So vomiting is reverse swallowing, kind of weird. Okay, all right, we'll move on down, looking at the, she does a little thing on teeth here. It's kind of interesting here that we have kind of a weird term. The baby teeth are called primary teeth, which I think is stupid. Primary would be your main teeth, I would think. But the better term, a lot of books call them deciduous teeth. That comes from botany. Those are your trees that shed their leaves. So deciduous means to drop. So these are the teeth that you drop. You have 20 baby teeth. Incisors, canines, and molars are for grinding. Canines are the things that look like a fang to grab and hold the animal down until it dies. And incisors are little blades up front. All the little ones are sharp. These all come out, fall out, and then we get our secondary teeth or permanent teeth, and there are 32 of those. So there are 20 baby teeth and 32 permanent teeth. Then there may be a third set of molars, the wisdom teeth, that can pop up sometimes in the back. You may have had those removed. Here's a cool picture showing them. Pretty wild. Not going to go crazy on teeth, but just do know that they're the primary and secondary teeth. Okay, teeth itself, take a look at the structure of it here. I like the pictures better than all these. She writes everything out. The enamel is the hard part that we talk about, that the cavity is when a bacterium bores a hole through it into the dentin layer. Then you have this cementum. I love this name. Cementum is what holds the tooth in. And then there is a periodontal ligament that holds teeth in. So if you ever have a tooth pulled, you have to pull that ligament off. And the cementum is a real tough layer there that grabs the tooth. We talk about, I won't bore y'all with a lot of teeth talk, but there's a lot of link between cardiovascular problems and teeth decay. A lot of the bacterium that cause cardiovascular disease get in the bloodstream, especially people who have real bad teeth, rotten teeth, and that can cause heart problems. So I know a lot of people have to take antibiotics before they have dental work done. Of course, flossing is trying to knock the plaque off. You need to do that every day, or just builds up. Fluorine in the water. Oh, now why that did that, I don't know. Maybe have somebody join us here. Let me go back and look real quick. No, we ain't got anybody new coming in. Don't know why it did that. All right, hang on. Don't know what I did there. I hit the wrong button. That's not working. Sorry about that. Hang on. I gotta get this. I gotta get PowerPoint working. Sorry. All right, let's see. This is about where we were. Let's see what we got here. I'm going to just skip through a lot of this if I don't think y'all can read through that. Let's see. She describes everything in here. Tongue. Don't have much there. The frenulum is the little meat under the tongue that anchors it to the bottom of your mouth. It's kind of weird. Then we got the glands in here, the salivary glands. They basically make two things: mucus to lubricate the food and make it palatable where you can swallow it, and then they make amylase, so we begin starch digestion in the mouth. So we actually start to break down starch in the mouth. That's kind of interesting. It talks about that. There's salivary amylase, also some lysozymes to kill bacterial infections in the mouth. We have antibodies in here too. And the saliva IgA that helps stop yeast infections in the mouth, which can be really bad in the throat. I have a friend of mine that had throat cancer, and they radiated her throat to kill the cancer. It killed her salivary glands, and she then doesn't make spit, and she has to drink water all the time. They even make synthetic spit that you can have that has antibiotics in it on a drip that you can put in your mouth. So it can be very debilitating if you lose these glands. We kind of take them for granted. The esophagus then just carries the food to the stomach. It doesn't have any digestive function at all, other than it's just a conduit tube from the mouth to the stomach. Okay, and you can see it here, kind of showing you the junction between the esophagus and the small intestine there. So basically, just kind of an easy tube here. You don't want to tear it. It doesn't heal very well. There's been a lot of I've read stories of people swallowing goldfish and stuff and cutting it and bleeding to death if you cut this. My dad constricts and he has to have a balloon blowed in and blows his back out. So a lot of people that get choked easily have to have this expanded. Acid reflux, if y'all got heartburn, that is when stomach contents blow back up and burn its epithelium lining of the esophagus. And that can be real painful. Y'all probably know people that dealt with that. I'm not going to do the whole, y'all can read through swallowing. There'll be a question about it. You can see here, it's pretty complicated reflex just to swallow. Okay, very cool. The stomach is our storage bin for the food. Different regions here, cardiac, fundus, body, pyloric region. Trying to get a picture of it. Here we go. We had a lab on this last week, so I'm not going to bore you with all the anatomy, but the main purpose here of the stomach is to store the food after a meal and to begin the digestion of proteins. We're going to see that it has these little folds called rugae. And in here, we have these gastric pits that make hydrochloric acid and an enzyme called pepsinogen. Pepsinogen is activated when the pH is below 4, around 2 or 3. And so that hydrochloric acid activates pepsinogen into pepsin, and we begin protein digestion in the stomach. Okay, now we all know if we've ever drank any, the stomach does absorb some stuff. We don't get a lot of food absorption, but it will absorb liquids. So if you drink on an empty stomach, you will get drunk very fast. You can get real dizzy real quick. And if you're drinking and eating a whole bunch while you're drinking, you can drink more because the food will absorb a lot of the alcohol. So, but alcohol can be absorbed in here, and it can be quite dangerous drinking on an empty stomach. Here's a photograph of cadaver stomach. You can see the little folds in it. The gastric glands, we were talking about these gastric pits. Look at this. So here's the epithelium lining. Look at these pits where the air is. So down in these pits is where we're going to have 3 chemicals made. We're going to have mucus to line the stomach so you won't burn a hole in your stomach. And then hydrochloric acid to create that pH at 2 to 3. And then the precursor to the enzyme pepsin called pepsinogen. Okay, you'll see it. These mucus cells make mucus. Parietal cells make hydrochloric acid. Also make a compound called intrinsic factor that allows B12 absorption. And the chief cells make this pepsinogen. So this is a really big deal. This is probably going to be a short answer question about this. But the pepsinogen is converted into pepsin in the presence of the hydrochloric acid. Now, the other thing that's interesting is if you have a condition called an ulcer, you make too much hydrochloric acid or not enough mucus, this acid burns a hole in your epithelium lining, and that's very painful. So you burn a hole in this. If it gets down into the blood vessels, then that's called a bleeding ulcer. And so y'all know the story of this. Hold on, we got some people trying to get in here. Hang on. People get here on time. Who's trying to come in here? Here we go. Miss Claiborne, come on in. We're going over it here. Anybody else out there? I've got a waiting room, sorry. She get in here? I think she just left. Probably just got irritated. Let's see. We had 6, now we're down to 5. Where did she go? There she is. There's Miss Claiborne. What's up? All right. Yeah, I've got to put a little security on it. They've had some people breaking in, doing some crazy stuff on Zoom meetings. So we're kind of going through the digestive system. Sorry about that. It started beeping there. So you got to give me a second there. Okay. So it's kind of one of the more interesting science stories of the last 30 years has been y'all heard of Tagamet and Zantac? These are 2 drugs that were very popular in the 90s and the early, maybe 15, 20 years ago. These were 2 drugs that were the biggest selling drugs in the world back in the around 2000, 2010. One of them makes you make more mucus, and the other one cuts off hydrochloric production. And these are the 2 most prescribed drugs in the world for ulcers. I actually had an ulcer myself in 96, 97, and they give me the Zantac, and it was like $50 a pill back then. $50 a pill. Today, you can go to Walmart and buy it for a nickel a pill. But the funny thing about it is, see, both of these drugs, one of them made you quit making hydrochloric acid, the other one made you what? Make more mucus. So they were both what? Fixing the problem, but neither one of them were fixing the cause of the problem, right? So it'd be like your house is on fire and you've got a water hose, you get more water on it to put it out, or you can cut the gas off, but you're still not solving the problem that you have something setting your house on fire. And so the guys, two gentlemen, discovered a bacterium growing in the pyloric region of the stomach. They isolated, grew it, and they hired people to be scoped to show that they don't have ulcers. Then they give them the bacterium and give them an ulcer. And consequently, they won the Nobel Prize for Medicine for that, because it was way outside the normal thought. Every book, every biology book, every medical school book, every book on earth said that all ulcers were caused by stress. And they proved that probably 70% of them are actually a bacterial infection that can be treated with $4 worth of antibiotics. So we normally don't give the Nobel Prize for something like that, but because they were going against the consensus, and they went and used science to prove that that it wasn't stress. So if you've ever had an ulcer, it can be caused by stress, but more commonly it's a bacterial infection. And we got to note that, because that's pretty freaking cool. And I think she makes a note about that somewhere in here. More hormones involved here in the stomach. A lot of hormones. There it is. There's down in those gastric pits. You can see those cells making our chemicals we're talking about. And she goes in a little bit more detail into how the hydrochloric acid is produced by the pyrrole cells. I'm not real worried about that. But look, there's the hydrochloric acid. The chief cells make pepsinogen. The pepsinogen is converted to pepsin, and we begin protein digestion. And this is hormonally controlled too, down in the stomach. Talks about phases of this. I'm not correct, but cephalic is when you see, smell, and start to taste the food. And then when it gets to the stomach, we get obviously all kind of hormones involved here, going down and preparing the stomach. So a lot of hormones involved here in controlling the pyrrole cell to make these acids. Then when the food hits the stomach, we call that the gastric phase, and all that's presence causes digestion to continue. You can see here's more hormones involved, up and then down. Somatostatin actually going down that's involved in this. Already talked about acid reflux. A lot of people take medicine of that. Here's another weird one. If the hiatal hernia is when part of the esophagus pooches out of the thoracic cavity, out of the abdominal cavity up into your lung cavity. And that can be real painful. My mother had this, and so when she had stomach bypass, they reached in and pulled her esophagus back down into her abdomen. Kind of wild. And there it is. The bacterium that they discovered was called Helicobacter pylori. And like I said, that revolutionized the treatment of this, and they won the Nobel Prize because of that. That's pretty cool. Okay, then the intestinal phase, final phase, where we're going to put this down in the small intestine. Okay, once again, a lot of hormones involved, a lot of negative feedback going on here to control the juices in the stomach. Okay, and she mentions vomiting, and et cetera, et cetera. Had another kind of weird stomach story. I had a student one time, still friends of mine. She was about y'all's age, kind of like Gabby. I knew your mom and dad as a kid. You know, I knew them. I knew this little girl too. She was here from Senatobia. She took me to A&P, then she went to Ole Miss, and then I got a call from her parents, and she was very sick. They still don't know what happened, but they think she never had chickenpox and got chickenpox as a 21-year-old, and it went down, the nerves went down and killed her stomach. So basically her stomach was paralyzed. They tried to shock it. They put a pacemaker on it. They couldn't do anything. They actually told her she probably wouldn't live 10 years. She's still going. She's like 45 years old today. So it's been almost 25 years. But she had to take so many pain pills that I've been told that one time she came in and they give her enough, morphine to put a horse down, and it didn't even faze her because she had to take so many pain pills. She was her tolerance was extremely high. But she is a nurse today. She is a nurse. She went to nursing school because she wanted to do something to help people, but her stomach never did work. She has to drink pre-digested food that comes all the way down. So it just goes straight into her, goes straight through and to her stomach, to her small intestine. Vomiting is reverse peristalsis. We talked about that already. Let's go down to small intestine. I would tell y'all too, this thing, they're supposed to be getting me a pro account. So if it goes out here in a few minutes, we just log right back into the same class. But I was going to try to knock this, kind of walk through this chapter, and I'm going to look like we got 10 minutes. I've already told them to get me an account, but so if we have to, just log right back in. I'm just going to open it right back up. irritated with that, sorry. So here's the deal. So now we get the small intestine, which is 20 feet long. The whole digestive tract is about 28, 30 feet long. And this is where we're going to absorb all our nutrients. Look at this. We digest, complete digestion. We absorb almost all the nutrients here. 95% of the nutrients absorbed here. And so this is the holy grail where we absorb all of our food. Stomach, some liquids, and the large intestine just sucks water out of poo-poo. That's its job, is to concentrate the fecal matter so we don't, if you lose too much water, that would cause dehydration. Okay, of course, that's diarrhea. Y'all know cholera that we all been vaccinated for kills children in third world countries because they basically have diarrhea themselves to death. So cholera is one of the still top 10 causes of death on earth. So it's very important that the large intestine gets the water out of it so we don't dehydrate ourselves. But if we get too much out, then we get constipation, right? And those are coming up later. But let's look at real quickly, look at the small intestine, duodenum, jejunum, and ileum. Ileum, get my story straight. The duodenum is the first part. The jejunum is the second part. And then the ileum is the last 10 feet. Okay? So basically here it is, all stretched out. And the whole purpose of this is to absorb the food. When they do stomach bypass, they remove the stomach and make it about a half a cup, maybe a cup size, like right here where I'm rubbing. And then they cut down like to here and attach that and throw the rest of the small intestine out. So if you ever have that done, my mother actually had this done. This is really dangerous because if they cut too much out, you could die because you can't absorb enough food. If they don't cut enough off, then you're still obese and you would be very mad that you paid $30,000 and then you went from 300 to 200. So very dangerous procedure. Almost 75% of them have complications. My mother, actually, I had it done against my will, just called me one Friday and said, I'm going in Monday to have this done in Little Rock. And I said, no, you're not. And my doctor friend that I talked about in class in Boonville, he didn't like it, but she had been following this doctor and he had done it for years. And she went up to Little Rock, had it done that next Monday. And he said, if you have problems, go to your local doctor. Well, she calls me on a Tuesday saying that her incision is very hot and swelling. And of course that was inflammation. It was infected. And I told her to go to my best friend in Boonville to the hospital, to go to the emergency room, go to him. When they got to the hospital and to the doctor's office in Boonville, my dad goes around to get my mother out of the car and it ruptures and she spews about 2 gallons of fluid all over the windshield, all over the car, all over everybody. My dad runs into the office screaming, and my best friend comes out, and when he gets to the car, he thought my mother's stomach had ruptured and she was about to die. So she rolled her into ER and emergency surgery, and when they got in there, her surgery was intact, but she had gotten infected under her skin, and so she had like 3 gallons of pus in between her abdomen. Yeah, under her skin, but not in her abdomen. And so I'm waiting on a phone call, about thinking my mother's dying. And he calls me up. And he says, well, I got good news and bad news. What do you want? I said, give me the bad news first. Or the good news first is your mother ain't dying this week. Her heart's really good because I would have had a heart attack and died because I thought her stomach ruptured. And it wasn't. It was an infection, but the bad news was she had an infection of it. But that's a true story, really bad experience with stomach bypass for her. But she did lose a lot of weight and gained a lot of it back. Because if you keep eating too much, your stomach will expand back out. But pretty cool organ here. We've already seen it. Remember the little villi, the little fingers in there, right? We've already seen this, right, for how things are absorbed. Remember, so the villi are these little fingers. And inside we have capillaries and lymphatic capillaries. And remember, fats are going to be absorbed in the lymphatic capillary called lacteals. And then sugars, proteins, and nucleic acids get absorbed into the bloodstream here. Okay, the little hair structures on the edge, the little purple haze is microvilli. And look at that, unbelievable. To make it real simple here, this is about 20 foot laid out. It'd be about the size of your hand at 20 feet. The villi increase the surface area to a tennis court. And if you cut the microvilli off, it would cover 80 yards of a football field. So 20 yard all the way, 0 to 20 to 80 to 20 yard line on the other side, 50 yards wide. So pretty much everything we eat gets absorbed here except cellulose, and that makes the roughage fiber. So we'll continue to have a bowel movement. So pretty much you can just say kind of goes into it in a little bit more detail, but that's kind of the gist of it. So it gets pushed through here, we absorb it. Look at here are all the hormones involved. in the digestive system. Tremendous number of hormones involved. These are the ones from the stomach. Let's see here. Stomach.
Do we need to know that? Do we need to learn these hormones?
Some of these are going to be on the test. Yeah, there'll be some of them on the test. Not going to have them all, but some of them.
Okay.
I like to say this one, cholecystokinin. That's a big one. Look at what all it does. It causes the gallbladder to release bile, stimulates the pancreas to make, we haven't talked about the pancreas, but the pancreas makes digestive enzymes that go into the duodenum that break down all 4 organic compounds, including DNA. So the pancreas has we already knew the pancreas made insulin and glucagon, but it also makes digestive enzymes to break down everything. And it makes bicarbonate to buffer the hydrochloric acid from the stomach. So the pancreas, as we'll see this coming up on another slide, but it's real important. And I believe I read somewhere in a book, I think this one, gastrin, was the first hormone ever discovered. The Germans did some research where they had I think it's German shepherds I saw, where they cut all the nerves to it and put a bowl of food out, and the side of the food made him produce gastrin from another part of the body that went to the stomach to make him make juices. That was the discovery of the endocrine system, hormones, which we've already covered. Appendix, kind of a weird one here, a blind pouch in the small intestine where the small dumps into the large, actually in the large, in the cecum. Blind pouch function is really not known. However, now there's some data suggesting that it could be a storm shelter for the good bacterium in your colon. And that still, in my opinion, hasn't been proven yet. But you can live without it. But if it swells up, and we'll see it in just a second picture, then it will rupture, and that can cause fecal matter to be on all your abdominal organs. And that's really bad. You don't want that. Okay? So we see here, look, the large intestine is going to absorb water and electrolytes. And basically, that's it. And suck that water out so that we can have a controlled amount of feces. I'm looking for a picture here. Lord, she's good with these words. There we go. So there's the cecum. So the small attaches here at the cecum. Then we have a ascending, transverse, descending, and then the sigmoid colon, and then the rectum and anus coming out here. So you have a ascending, transverse, descending, and then this little bit of sigmoid colon and the rectum where we store feces. Of course, we need to mention here that one of the most common types of cancer is colon cancer, where you would have this tumors growing in here and these polyps in the lumen, and it's treatable by having a scope done and having those tumors and polyps removed. Valves in here, the anal sphincters and all, allow us to control defecation. Here we go. We've got 2 of them here to help us control poo-pooing. Okay, our number 2. What else we got here? The bacteria making up this is pretty wild. Look at this. It's been a cut off too, by the way. We almost finished this chat. We got not quite that, almost over halfway. But the normal flora, over 500 different species of bacterium in the colon. 10 times more bacterium in the large intestine than all the cells of your body. And they make up 60% of the dry weight of feces. So 60% of the weight of feces is bacterium that we do not want to put back in our mouth. So this is why we wash our hands after we do a number 2. You don't want any of this to get back in your body. That's bad news. Okay, and she's going to talk about that quite a bit. And I think we almost got through with it. We just like the accessory organs now. So defecation's fancy name for number 2. Reflex control. Diarrhea is too much water going through, right? Not enough water being absorbed. And constipation is too much water being absorbed. We've all been on a trip with Daddy and Mama, and Daddy gets in the car. We're not going to stop to Panama City, right? Then you're constipated when you get there. Here's a great summary of all the functions of these different organs. What we haven't hit is the pancreas and the liver's role, and we'll look at that in just a minute. I think we're going to have to log back in. The stupid thing's going to cut off on me. It does not like me. So the first one is going to be the pancreas. Okay. And of course, we've already covered this before. It has an endocrine function of making hormones, insulin and glucagon that control sugar levels. But equally important is this exocrine function, making enzymes to break down all 4 food groups. We got some more people joining us here right at the end. Okay, let me get these people and tell them if they want to